first example at the bottom of that first page you have. This is a graph that's set up. It's got everything in place that we need so that we can get started. My first graph that I see, my first function I'm looking at, this one only has two pieces. It has piece number 1, piece number 2. So what happens is, if I'll take a look and I see what I have x squared minus 4. You could almost read this like this. The g of x function equals, it has two parts. The first piece is x squared minus 4 if the x's are between, or if x's are less than or equal to 3. That helps me define where I need to look for that piece of the function. I'm also going to look at the second piece of the function, which says g of x also equals x plus 2 if the x's are less than 3. The first thing I notice is that I have a number in common. It's almost like the number 3 on the x-axis is going to split my two pieces, and one side's going to be one piece and one side's going to be the other. So I'm going to come to x equals 3, and the first thing I'm going to do, you can take a highlighter or you can take just a marker or a pencil and you can draw a dividing line. I usually do like to do a highlighter because that means you can still write on it, write through it, and you can still just see it. So we're going to basically know that my first piece is to the left, okay, and my second piece is going to be graphed to the right, because that's how it's divided. It says x's that are less than or equal to 3, or x's that are greater than 3. Less than 3, greater than 3. All right. Now to evaluate the function, let's keep in mind that these x's that we have here in the table's already set up for us. We are just evaluating the function at all of these x's. -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Notice that basically we have 3 right in the middle. And remember, 3 happened to be that point on our graph, on our domain, that separates our function into two pieces. Notice that I have points that are less than 3 and numbers that are greater than 3. And so if I can graph behind 3, at 3, and greater than 3, I'll be able to see what the entire graph looks like. So I'm going to evaluate the function at these points. So if I pretend, if I'm going to use -2, it's kind of like doing g function at -2. And if I take a look, I observe that g, -2, is a number less than 3. Since -2 is a number less than 3, I'm going to use the first piece. So I would actually have to use -2 squared minus 4, because that is what the first piece looks like. I'm going to put my -2 in parentheses, and that makes it negative times negative, which is positive 4, minus 4, which is going to be 0. So the first one becomes 0 in my table. I'm going to repeat the idea with -1. -1 is going to go up here. It's going to get substituted in for x. It's going to be squared minus 4. -1 times -1 is positive 1. Positive 1 minus 4 is -3. I'm going to repeat with 0. 0 is still less than 3, so I'm still going to the first piece. This is going to look a little bit messy for now. I'll erase that in a second. 0 squared minus 4 would be minus 4. Same thing with 1. 1 squared minus 4 is -3. Put 2 back in the same piece. 2 squared is 4 minus 4, which is 0. I'm finally at my number 3. And when I look at number 3, I finally get to the point to where my graph is separated. Okay, so far I've done everything that I needed to for all of the points behind 3. 3 is kind of like that handoff point. 3 is the point at which we want to see where does the first piece bring the graph to, where does the second piece take the graph from in regards to 3. So I'm actually going to use 3 in both pieces for graphing purposes only. So I'm going to put 3 into the first piece. So 3 is going to go to my first piece. 3 squared minus 4 is going to make it 5. I've actually finished my first piece. If I wanted, I could graph the points, and I'll do that in a moment. What I'm going to do next is I'm actually going to use 3 in my second piece. Even though it doesn't say equals 3 in the second piece, it only says greater than 3. I need to know where does it pick the value up and where does it take it from, okay? So I'm going to put 3 also in the second piece, but only number 3, and only because it's that handoff point, only because it's that number that separates our graph right in the middle here at positive 3. Okay? All right, so if I put 3, 3 plus 2 becomes 5. And it turns out that where the first piece brought it to, 5, the second piece is going to pick it up at the exact same point. This is going to be a nice, continuous, smooth graph. Now, we're numbers bigger than 3. So now we're only using the second piece. Only using the second piece. So 4, okay, if I put a 4 up here, 4 plus 2, 4 plus 2 is 6, and I repeat the process, 5 plus 2 is 7, 6 plus 2 is 8, 7 plus 2 is 9, 8 plus 2 is 10. I now have a lot of points that I can put on my graph. Okay, all right, just trying to clean this up just a little bit because it does look a little messy. Or Miss Jessup has put all of these points and tried to draw lines to show you where I was working. I'm now ready to plot points. This is like your x's and these are like your y's. So the point becomes like -2, 0, -1, 3, okay, 0, -4, and so on. So I'm going to plot those points. -2, 0, -1, -3, 0, -4, +1, -3, +2, 0, and 3, counting up 5, 1, 2, 3, 4, 5. And I'm actually going to use a closed circle. The reason I'm going to use a closed circle is because it says greater than or equal to 3. All right, this side of the graph looks like a parabola. And I'm going to actually use an arrow because this one does go to numbers beyond -2. It says all values of x less than or equal to 3. And there are a lot more numbers. I can see the shape and I know the pattern, so I'm going to draw my arrow saying that I know the graph continues in that direction. All right, I'm now going to switch colors and I'm going to graph the second piece of the function, starting with 3 and this 5. So that would be on the new graph 3, 5. Now technically, starting at that point, I would use an open circle because this one does not have an equals. So starting with my second piece, I'm actually starting with an open circle. If I didn't have two colors, you would not be able to distinguish the two different colors. Okay, let's continue. I'm now going to plot 4, 6, 5, and 7. That's like my x and my y, and I'm going to plot these points on the graph. So I'm going to go over 3 and 5, 4 and 6, and 5, 7, 6, 8, and so forth. This graph is actually going to be a straight line. I know that there are a lot more numbers past 8, like 9, 10, etc., etc., and I know the graph's going to continue up and to the right, and that's why I'm going to put an arrow on there, because again, my domain says all x's greater than 3 on the second piece. All right, to answer the questions, explain which function is defined at x equals 3 and y. The answer is the first piece. Why? Because the first piece has an equals. It says x less than or equal to 3. And because it has the equals on the 3, I only use the first piece to give me the exact answer for the value at x equals 3. Last thing on this introductory problem, describe the graph of the function. Okay, we noticed that when we separated our graph into two sections, I have less than 3 and greater than 3. I have a left-hand side and a right-hand side. The left-hand side has a particular shape, and the left-hand side function looks like this. So if I was going to look at the function, it says x squared minus 4. And here's the equation of x squared minus 4. I hope that you recall that that is a quadratic equation. So the first piece is a quadratic equation. It has x squared in it, and the shape of the graph is a parabola. Okay. I hope that you can see with me, if we look at, I now have the second piece of my function says x plus 2. That's x to the first power. I hope you remember that x to the first power is a linear function because it has x to the first power in it, and I know that all graphs of x to the first power generally are all linear. So what I have is I have a piecewise function. I have brought two totally related, unrelated functions together, but I'm only looking at small pieces. Here I'm only looking at from 3 behind, for my parabola and from 3 forward on my line. We'll go on to the next one.